Good morning, students. Today we are going to solve the problem of centrifugal pump. So here one question is given based on the centrifugal pump. See the question carefully and read it and understand clearly. So the centrifugal pump has external and internal diameters of impeller as 700 mm and 350 mm respectively, and the vane angles at inlet and outlet are given 25 degrees and 45 degrees. If the water enters the impeller radially at 4 meters per second, determine speed of the impeller and work done per kg of water. So this is the given question. So what is the given values? Impeller inlet and outlet diameters are given, vane angle at inlet and outlet are given, and speed of the water at inlet are given. So these are the values given, and you are asked to find the speed of the impeller and work done per kg of water. Those values you have to calculate. So for that, so you have to write all the given values clearly. So write the given data. External diameter, external values are indicating with symbol 2 and internal values with 1 suffixes. So external diameter d equal to 700 mm. Convert that value into meters, 0.7 meter, and internal diameter is d1, 350 mm is given by converting into meters, 0.35 meters, and vane angle at inlet, that value is theta, 25 degrees, vane angle at outlet pi, that is equal to 45 degrees, and water is entering radially, so that means it is radially entering. So alpha is equal to 90 degrees. When alpha is equal to 90 degrees, VW1 parameter becomes 0, and velocity of water at inlet is given V1, that is 4 meters per second. And by considering the blades are smooth blades, we can write V1 is equal to Vf1 and Vf1 is equal to Vf2. So Vf1 parameter is equal to Vf2 by considering the smooth curved blades. So these are the given values for the question. And before going to solve the problem, we must understood the concept of that velocity triangles for the centrifugal pump. Here the velocity diagrams are given, and this is the impeller inlet diameter and inlet outlet diameter that blade is considering. So this is the inlet point for this blade and this is the outlet point for the given blade for this impeller. So water is entering radially, that means from the center it is coming radially with 90 degrees. That is why here considering the alpha is equal to 90 degrees. So radially it is entering at this inlet point, and blade is moving in this direction. When blade is moving in this direction, tangential velocity at this point is considered tangential towards this side. So this is drawn below to this point to consider the triangle. So this is the blade velocity represented with U1, and water is moving in this direction and blade is moving in this direction. So we are considering the taking the relative velocity. So by joining those two lines, we get the relative velocity. So we are just considering relative velocity VR1 at inlet. So U1 is the blade velocity, V1 is the velocity of water, and VR1 is the relative velocity at which it is water is entering at the inlet. Now, similarly, come to the velocity triangle at outlet, and water is leaving in this direction V2, so leaving at this direction, and blade is also moving in this direction. So tangential velocity at this point is like this. So we are considering that one above to this point. So in order to complete that triangle only, so we are drawing in this direction. So velocity of the jet is water is in this direction, blade velocity is considered here. So to join this one, this is the relative velocity. So relative velocity at outlet. So VR2 is the direction of this one, V2, U2 and VR2. So V2 is some inclination, that is why you have to resolve this one into two components. One is vertical component, horizontal component. So vertical component is VF2 and horizontal component is VW2. So here there is no VW2 component because 90 degrees of inclination, but here beta some angle of inclination considering, that is why resolving into horizontal as well as vertical component. So this is the velocity diagram at outlet and inlet. By using these two inlet and outlet velocity diagrams, we are going to solve the problem. So now coming to the problem. So he is asked to find the speed of the impeller. So how can you find the speed of the impeller? By using the formula, speed of the impeller at inlet U1 is equal to pi dn by 60. If we are considering at outlet, the speed is pi d2n by 60. You can use any these two formulas. So we are taking this formula first and finding the n value. So speed is the n value of speed is nothing but the n of this impeller only. So that is why you have to find using this relation and finding the n value. So to find that, when d1 is value is given but u1 value is not given in the problem. So by using the velocity triangle of this one, you have to find the u1 value. So how will you find the u1 value from this diagram? Means you can take the inlet velocity triangle of this one, ABC triangle, and from this theta is given. So here is the theta value. So you can write any of the theorems, that is tan theta equal to tan theta is opposite by adjacent. So opposite one is the v1 value, adjacent one value is u1 value. So from that relation you can write tan theta equal to v1 by u1. So you have to find u1 value. So just take this one to this side and tan theta to the right side. So u1 equal to v1 by tan theta. v1 value is given 4 meters and theta value is given 25 degrees. So by substituting those two values, you will get the velocity is equal to 8.58 meters per second at inlet. So at this point, the blade velocity or this impeller velocity is equal to 8.58 meter per second. So that is. So you got this one value. So now we can go to find the value of n value by using this formula. So from this formula you can rewrite u1 equal to pi dn by 60. So from this you can write the n value is equal to u1 into this, take this value 60 to this direction, and pi d1 you will get below to the line. So n is equal to 60 into u1 by pi d1. So by substituting u1 value and d1 value, 60 into 8.58 by pi into 0.35, you will get to 468 rpm, revolutions per minute. So the speed of the impeller at this point, so at this point you got the 468 rpm. So always speed at any point is equal. You may consider at outlet or inlet, but the speed of that impeller is same. So 468 rpm. So you got the first value, speed of the impeller. Now we have to go for the finding the speed work done per kg of water. So work done, to find the work done per kg of water, the formula is VW2U2. This is the formula to find the work done per kg of water. So we have to find VW2 value and U2 value. So to find the U2 value, use the relation U2 equal to pi d2n by 60 only. So by tangential velocity of water at outlet is equal to pi d2n by 60. Using this relation, you can find the velocity of this blade at outlet is equal to 17.15 by substituting the d2 value and n value. N value is 468 and d2 value is 0.7 meters. You get 17.15 meter per second. Now second value you have to find VW2. So to find the VW2 value, we use the velocity triangle at outlet. So VW2 value is this one. To get this one, it is you cannot get from this triangle. So that is why you are considering GFE triangle, and pi value is given, vane angle at outlet is given 45 degrees. That is why just we are utilizing this one. So here with this triangle you can write tan pi equal to opposite by adjacent. opposite by adjacent. So opposite value is Vf2 value, adjacent value is difference of these two values, U2 minus Vw2. So this value is not given directly, but total value is given, and other part of this one is also given. So you can take this value by taking the difference of these two values. So tan pi equal to Vf2 by difference of these two values. So that we are writing here, tan pi equal to Vf2 by U2 minus Vw2, where Vf2 is equal to Vf1. Vf2 is equal to Vf1, that is equal to V1. So that is why just considering V1 value as equal to Vf2 only. So substituting that values, and U2 value is calculated from this formula. So Vw2 value have to know. By rearranging this formula, U2 minus Vw2, V2 minus Vw2 this direction, and tan phi to the other side, U2 minus Vw2 is equal to Vf2 by tan pi. And once again rearranging this value, Vw2 value we have to calculate, that is why Vw2 can be written as U2 minus Vf2 by tan pi. So by taking this one to the other side and this parameter to this side, we will get Vw2 equal to U2 minus Vf2 by tan pi. Now we can directly substitute all the values, U2 value, Vf2 value, tan pi value. U2 value is 17.15 and Vf2 value is 4 and tan pi value is 40, tan 45. So substituting all these values, you will get this value is equal to 4, and difference of this value is 13.15 meter per second. So this is the Vw2 value, that is the wheel velocity at outlet is equal to 13.15 meter per second. So you got the Vw2 value and U2 value. So then directly work done can be easily calculated with this formula. Work done per kg of water per second is equal to Vw2 U2. So Vw2 is 13.15, U2 is 17.15. By multiplying these two values, you get the 225.52 Newton meters. So work done per kg of water per second is equal to 225.52 Newton meters. So in this way you can calculate, or you can get the solution for this centrifugal pump. Thank you.